Lesson 26 is one of our more lessons. You'll notice it says more complicated equations. A lot of times when we have a more lesson, that means we're not really learning anything new. And this is the first example, 3x minus 4 equals 5x plus 7. You might say the one thing that is sort of new is step 2. We're going to first simplify both sides of the equation. So here's this indicates that we have an equation, so we're going to simplify both sides. So we're going to take a look at this side, simplify it, take a look at the left side, and also simplify it. What's sort of new is this right here, but not really, because we're going to use the idea of doing the same thing to both sides of an equation to accomplish it, and then finally we're going to solve. So we look at this as an equation. We've got two sides to it. They're balanced right now. We simplify both sides. When we simplify both sides, what we're really saying is, are there any like terms we can combine on each side? In this case, you have 3x minus 4. There's nothing that can be simplified or combined. And then on the right side, you have 5x plus 7. There's nothing that can be combined. So there are no like terms to add. You'll see in the next example, there are some terms to add. So we go right to step 2. It says get variables on one side of the equation. Our variable is x. So what we want to do is bring all the x's to one side, because obviously our goal is to get x by itself on one side of the equation. We can't have an x on one side of the equation and an x on the other like we do right now. So we're going to need to get the x's to both sides. Another way of saying that is, let's eliminate the x's from one side. So I have two choices to do that. The first, if I have positive 3x here, to eliminate the x's from this side, I would subtract 3x. That's one possibility. We could subtract 3x from both sides, and it would eliminate the x's from this side. Another possibility, which would work just as well, would be to say here I have a total of positive 5x, so if I subtracted 5x from both sides of the equation, that would eliminate the x's from this side of the equation, which would help me to get to just having x by itself on one side of the equation. So let's go back, and we're actually going to subtract 3x from both sides of the equation. So here these two cancel out. We have a negative 4 equals 2x plus 7. So we've got the x's to one side of the equation. Now we solve using inverse operations. Do we have x by itself? No. What are we doing to poor little x? Multiplying him by 2 and adding 7. So let's undo that. Subtract 7, negative 11 equals 2x. Still don't have x by itself. We're multiplying him by 2. How do we undo that? Divide by 2. What we do to one side, we do to the other. 2 over 2 is 1. 1 times x is x. X equals negative 11 halves, or negative 5 and 1 half. Alright. In our next example, we've got negative 7n plus 3 plus 2n equals 4n minus 5 plus n. So in this case, there are going to be some things we can simplify, or like terms we can add, in this case on both sides of the equation. So it's almost as if we treat these as separate problems. We're not even going to look over on the right side here. We're just going to deal with the left side here and say, what can we simplify here? Are there any like terms? Well, here's a term, here's a term, and here's a term. Negative 7n plus 2n are like terms. We can simplify them, add them, and we would have negative 5n, then bring that 3 as well. So we simplified the left side. All we did was add our like terms. Now we look at the right side. Here we have a 4n plus another n is a total of 5n. Those were like terms. And then we have our minus 5. So we simplified both sides of the equation. There's nothing else we can simplify. So now we go to step 2, which is bring the x, or the n's in this case, to one side. Let's get n by itself. So we're going to eliminate n's from one side. Let's add 5n to both sides. A negative 5n and a positive 5n cancel out. Over here we just have 3 equals 10n minus 5. Our goal is n by itself. We don't have n by itself. We are multiplying it by 10 and subtracting 5 using our inverse operations. Let's work to get n by itself. 8 equals 10n. Still don't have n by itself. What are we doing to poor little n? Multiplying it by 10. How do we undo that? We divide by 10. 10 over 10 is 1. 1 times n is n. N equals 8/10. We should reduce that. N equals 4/5. Let's do one more problem. Our first step is to simplify both sides of the equation. So again, we just start with the left side, almost pretend this isn't even here at this point. Let's just look here and see if there are any like terms we can add. Term, term, and a term. A positive 7x and a positive 2x are like terms for a total of 9x minus 5. Over here, is there anything we can simplify? We've got a term, we've got a term, and we've got a term. We can simplify 5 and 10 to be 15. Step 2, bring the x's to one side, or eliminate the x's from one side. I've been intentionally making it so that I always keep the x positive. So my preference right now is to subtract 3x from both sides because that's going to keep this positive. The x is a positive 6x. I've been doing that on purpose so far, but let's just show what it looks like. I wouldn't have to. We could also subtract 9x from both sides. The reason I prefer not to do that is it's going to make my x's negative, but that's not a huge deal. Let's do one like that just to show it's not a huge deal. Positive 9x, negative 9x equals 0. So we've got negative 5 equals, now here I've got negative 6x. See, I've got a negative form of x, which I avoid when I can, but let's do one like this. Goal is x by itself. We don't have that. We need to subtract 15 from both sides. We've got negative 20 equals negative 6x. So here, we're trying to get x by itself. Multiplying it by negative 6, how do we do that? Subtract negative 6, or divide by negative 6. So a negative divided by a negative is a positive. So x equals 20 over 6. We want to reduce that 10/3. Really, we don't have anything new as far as concepts. The one step that's a little bit new is right here. We want to get the variables to one side when we're solving these things, or to help us solve these things.